Alright, so we're looking at f of x is equal to 4 divided by, there's a hint for domain, divided by square root x minus 4 plus 9. Okay, when I see division, I need to make sure that I'm not dividing by 0. So off the bat, and we're thinking domain, you should make sure and make a note that, hey, x cannot equal 4, because that would produce a divide by 0. Now the division's taken care of. All you have to worry about is dividing by 0. But now you have to consider the square root. You can only take the square root of positive numbers. So, could x be 10? Sure. 10 minus 4 is 6. You can take the square root of 6. Could x be 5? Yep. 5 minus 4 is 1. Square root of 1 is fine. If x was 3, well, 3 minus 4 is negative 1. I can't take the square root of it. So you're starting to get an idea of the numbers you can use and the numbers you can't. So as far as the square root goes, you're not going to be able to take the square root of numbers that are smaller than 4. Right? So what's the set of, how do you describe the set of numbers that are not smaller than 4? How do you describe the numbers that are larger than 4? Well, you'd say from 4 to infinity. Right? There's my domain. Now, there's a reason we put an open bracket here. Right? If you were just considering the square root of x minus 4 as your function, right? If, let's say this was a separate function, h of x, and I said, what's the domain? Well, the domain of that function would be, well, from 4 to infinity, closed on the 4. Well, how come you close the 4 there and you don't close it here? Well, we had to worry about the divide by 0. Right? So that's why down here I'm going to leave it as open 4, because you can't divide by 0. Plugging in 4 would produce the divide by 0. Right? So as long as we're bigger than 4, we're fine. So we've got the domain. Now we'll go to the range. So range is about output values. So if you take all of these numbers in here and plug them in for x, think about the different outputs you're going to get. Okay. Well, just that yellow piece right there, the square root of x minus 4, we're not going to be allowed to make it 0 because it's in the bottom of that, but what will that thing lead to? Right? What will that thing output? Well, we said no 0. Will it ever produce negative things? No. No matter what you plug in for x, being that x is appropriate, it's never going to be negative. It's always going to be positive. Right? So you've got this 4 in the numerator, right? And you're going to divide it by different things, and those things are going to go all the way from 0 non-inclusive, because we don't want to divide by 0, to infinity. So let's go down here. What happens when you take 4 and you divide it by kind of a different notation, but this number set, 0 to infinity? What happens to 4? Like, what does this produce? What does, if you plug all those numbers, all the various numbers in, well, when you plug 10 in, 4/10 is 0.4. But if you try to divide 4 by all of the numbers in that set, you're going to get new numbers, right? New outputs. Okay, will you get really big outputs? Sure. Yeah, there are really small numbers in here, like 0.000000001. 4 divided by that, that's really huge. So it's possible to make this thing here really big. Just make sure you pick really, really small values in here. It's also possible to make it really, really small, right? If you pick the bigger numbers in this interval, well, 4 divided by really big numbers is really small. So this thing here, this box, right, if we consider what it's going to output, well, that thing's going to output things, well, we said. You can get really big numbers if you plug in small values, and you can get small values out of that if you let the denominator be very big. So just this piece right here, that thing is going to output values between 0 and infinity, not including 0. So you know what this does. that thing produces outputs that range from 0 to infinity. Now, all you got to worry about is you're going to add 9 to all of those outputs. Well, if you add 9 to the low end of that, add 9 to the 0, you're gonna get 9. If you add 9 to the high end of that, well, if you add 9 to infinity, you'll still be at infinity. So the range of our function is from non-inclusive 9 to infinity. Here's another way to go about it. Let me show you algebraically why we don't want to include 9 in the range. Watch what happens when you set, well, let's pick a number in here. Let's pick 50, right? 50's in there. That means 50 equals 4 over square root x minus 4 plus 9. Is there an x that you could pick that would produce 50 over here? Like, I don't know. Well, you could try to solve it, right? So if you solve this, you'd solve it by taking 9 away from both sides, and you'd have your 41 equals 4 over square root x minus 4. Okay, we're getting closer. And then I'd get rid of the fraction, so I'd multiply both sides by square root x minus 4. Okay, so no more fractions. That's kind of nice. Oops. So you got 41 square root x minus 4 equals 4. Okay. Now I'm going to go ahead, I don't have any fractions, I'm going to divide both sides by 41. Okay. So I got square root x minus 4 equals some decimal, right? Point something. Point number, right? It's just some decimal. Now you'd square both sides. So you got your x minus 4 equals, point something. Oops. Okay, so you'd add 4 to both sides. Hey, turns out x is equal to 4 plus whatever that number was. We had it as 41 fourths, or 4 over 41, right? So 4 over 41 squared. Yeah, you could type that into your calculator and you would know what x was. Right? So certainly we can say that 50 is in our range. Now I'm going to show you why 9 is not, algebraically. So instead of saying 50 equals, we're going to say 9 equals. Make some room down here. 9 equals 4 over square root x minus 4 plus 9. So you try to solve and you minus 9 and you minus 9. And you say, no problem, 0 equals 4 over square root x minus 4. Wait, I've got a fraction, and I need to get 0 out of it. The only way to get 0 out of a fraction is to get 0 in the numerator. The numerator is fixed at 4. That's never going to happen. Okay, you can't turn 4 divided by square root x minus 4 into 0. Well, what does that mean? That means that step back once. That thing, that's never going to happen. This equation will never equal 9. It's not going to happen. So 9 is not in your range. So you've got the domain, you've got the range of f of x. Now we just need to find f inverse. So this is more procedural for you guys. So f of x equals 4 over square root x minus 4 plus 9. I want to give you a way to check your answer in the end. So x, f of x. Let's say when x is 5. What's f of x? Well, f of x is 4 divided by the square root of 1 is 4. 4 plus 9 is 13. And we'll do one more. Let's go with 8. So if you plug 8 in for x, 8 minus 4, Right? 8 minus 4 is 4. Square root of 4 is 2. So you got 4 over 2 plus 9. So that's 2 plus 9. And we've got 11. So we're going to check, and when we get in F inverse, we're going to make sure that 8 maps back to 11 and 13 maps back to 5. And we'll do that. It's kind of your way to check your answer. So now we go with the algebra. So start with y equals 4 over square root x minus 4 plus 9. I want to isolate x. I'm going to subtract 9 from both sides. Okay, goal, isolate x, isolate x, isolate x. You know, I see a fraction. I'm going to go ahead and take care of that right now. Some of you might feel like I just took a step back, but that's alright. I'm not dealing with a fraction right now. There would have been some quicker tricks up there to isolate x, but that's okay. Now I want to go ahead. I'm still trying to isolate x, so I'll divide off y minus 9. We're getting closer. Square root x minus 4, you can square the side to get rid of that, equals 4 over y minus 9. Square both sides. I'm not super concerned with the simplification right now. So now you got x minus 4 equals 4 divided by y minus 9 squared. You can add 4 to both sides. So those go away. So we found the inverse, right? And we got something to check it with. So we're going to go ahead and say F inverse of x equals 4 over, replace y with x, x minus 9 squared plus 4. Now, go back to the work we did. That was going to allow you to check your answer. I'll go copy that. It was this thing. So when 8 goes into F, you get 11. When 11 goes into F inverse, you should get 8. So F inverse 11 equals 4 over 11 minus 9 squared plus 4. So 11 minus 9 is 2. 4 divided by 2 is 2. So 2 squared plus 4 equals 8. And that's what we wanted. We'll do one more. We'll check the 13. So when 13 goes into F inverse, you should get 5. So when 13 goes in, you should get 5 out. F inverse 13 equals 4 over 13 minus 9 squared plus 4. So that's 4 over 4 squared plus 4. Alright, I had to check. We want to get 5, and we did. 1 plus 4 equals 5. F inverse of 13 equals 5. F inverse of 13 equals 5. So you've got domain, you've got range, and you have your F inverse, and you have verified that it was correct with 2 instances. Later I'll show you how you can plug like F into F inverse and how that works. But this is just a quick check for right now, and a little less manipulation, and it's a real quick, convenient check for you.